All right, so these are your Geometry 4.2 lesson notes. It is about triangle congruence by side, side, side. That's what SSS stands for, and side angle side. That's what SAS stands for. So we're going to do about 5 of these triangle proofs, but we're just going to do 2, the first 2 today in today's lesson. So the first thing you should know is about the side, side, side postulate. So what this states is that if 3 sides of one triangle are congruent to 3 sides of another triangle, then both of the triangles are congruent by its side, side, and side. So if AB is congruent to DE, if BC is congruent to EF, and if AC is congruent to DF, then therefore the entire triangles are congruent by reason of side, side, side postulate. Okay, so here's an example problem of using side, side, side. So they have given to us 2 of the sides. So they gave us that LM is congruent to NP, so they've made one little hash mark here, it's already given. And then they've told us that LP is congruent to NM, so they've given it 2 little hash marks here. So we're trying to prove that the triangles are congruent to each other, and we're trying to use side, side, side. So we have 2 of the 3 sides, but we're missing this 3rd side. So what you guys know from previous lessons is that side LN would be congruent in this triangle and congruent to itself using it in the other triangle. So we can say that side LN is congruent to itself, side LN again, and this is by reflexive. It's not really letting us, I mean, we don't really need to set up an entire 2-column proof here, but we can mark these up and say that this side is congruent to itself, and anything congruent to itself is by the reflexive reasoning. And now we have this one, and this one congruent to this one, and this one. So therefore, we have now proven that the entire triangles are congruent by reason of side, side, side. All right, our second and final postulate for today is SAS, which stands for side angle side. So this one is basically the same. It's a tiny bit trickier because what it says is if 2 sides and the included angle, okay? So they're not saying some random angle. It can't be this one or it can't be this one. It has to be the one that's included, and what the word included means in geometry is the one between these 2 sides. So if it's this side and this side, then the only included angle is the one in between the 2 sides. So I hope you understand what the word included, the words included angle means. It means the one in between the 2 marked up sides. Okay, so if 2 sides and the included in between angle are congruent to 2 sides and the included, which means in between angle of the other triangle, then the 2 triangles are congruent by reason of side angle side. And that is why SAS is written in this particular order. The angle that's in between has to be between the 2 sides that are congruent. So let's practice. Using side angle side, prove these are congruent. So once again, we have a side congruent to a side and an angle congruent to an angle, but we're missing the other side. Okay, and it cannot be this side and this side because that would not be the side that puts the angle in between the 2. So it's going to have to be that AC is congruent to AC. And again, the reason we know AC is congruent to AC is because of reflexive, anything congruent to itself. And now that we have that marked up, what you notice is the angle is between the 2 sides. The angle is between the 2 sides, or included. Sorry, it's the included angle. I need to start saying the right word. So now we have proven that triangle, I'll just say ABC. Oh no, we need a side angle side. So triangle BAC is congruent to the other one in that order, which would be DCA, because we've proven side and the angle included in between side angle side. All right, let's flip it over to the back. these are just basically asking, would you use which one, side, 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 or side, angle, side, to prove these triangles congruent? And there may not be enough information. So if there is not enough information to prove by side, 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 or side, angle, side, we're going to say not enough information. All right, so A, I see a side, side. I see an angle, angle, side, side. So, and what I want you to notice is this angle is between the two sides. It's included. So that is why this is a yes. Side, well, I don't know if we needed to write yes or no, but this one is a side, angle, side. All right, on B, we have a side and an angle and a side, and another side and an angle and a side. However, the angle is not included in this one. It would need to have been right here between the two sides, and it's not. So these might be congruent to each other, but for right now, we do not have enough information. So we're going to write not enough information. All right, let's check out C. For C, we have a side, a side, and a side, a side, a side, and a side. So this is a yes. We can prove it by side, side, side theorem. And then last, side, 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 side. So this is also yes by side, side, side theorem. All right, let's check to be sure you got it. Would you use side, 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 or side, angle, side to prove the triangles over here are congruent? So I see that all three sides are marked, but the angle is between my 3 and 2 hash marks, and over here the angle is between my 1 and 2 hash marks. So it's actually not the same one, so the only thing that we could for sure say are the 3 sides. So for this particular one, we would use side, side, side theorem. And then the last 2 problems, name the postulate you would use to prove these are congruent. For this one, we only have 2 sides, and we can't go ahead and just mark the third side. There is a third angles theorem, but there's not a third sides theorem. So what you would need to do with this one is look at vertical angles. And now that you know vertical angles are congruent, we have a side and an angle included in between and a side. Side, angle, side. So this one we would use side, angle, side. And then the last one, we don't have any angles marked. But what you know is that if this side is shared with both this triangle and this triangle, then it's going to be reflexive, and it's going to be the same length in both triangles. So now we have a side, 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 side. So this one would be side, side, side.